I'm hoping that the fire safety team will talk first, and then I'd like to talk about how the regulatory room can work with the building project. So can I ask who's going to speak first?
Yeah, I'll cover the fire safety start, and then I'll hand over to Asim during the presentation. Okay, all right. So, all right. So, sorry for the technical glitch at the start. So we're going to present today with the overall progress on the fire safety engineering project, as we call it. It has been subdivided into two projects later on, but we're going to cover some of the original scope and how it's developed. And presenting today are myself, Peter Thompson. I was with Autodesk until recently, which is why I'm listed as with Autodesk on the agenda. I recently joined Movement Strategies, part of GHD, to focus on fire safety and evacuation modelling, and also have an adjunct position at Lund University. Asim, do you want to introduce yourself?
Yeah, my name is Asim Siddiqui. I work as a research fellow for Fire Safety Engineering Group, University of Greenwich, UK.
Great. So today we're going to be covering several items. First of all, really why this project is important and why we embarked upon the whole process. Our basic mission is to look at safeguarding life and property within buildings and to really try and complete the data loops in that area. We'll be covering some of the project scope from the outset and as they are now, how they sit in the context of the BSI rooms, how the working groups have expanded over time, and then an update on the progress of the two specific technical streams, one of which is now the more narrow and focused fire safety engineering information delivery specification plan, and then the pre-existing occupant movement analysis model view definition plan, project status on that. And then we'll have a summary and a general discussion, Q&A, and how that fits within the regulatory process as well. So why is this so important? Well, background, while BIM has become the standard platform, which we're all familiar with for looking at integrated digital design, really the fire safety engineering community as a group is somewhat behind the adoption of BIM. And there is a lack of standards and data points which are usually used in the fire safety engineering process, which are not catered for in the IFC standards at the moment. And really, as a result of that kind of gap in data, we're seeing frequent data loss in the fire safety engineering workflows for any team using BIM projects at their heart. Sometimes they will export the IFC file and they'll bring those packages into third-party analysis packages, but they'll have to rebuild the model, either augment the geometry or add in all the extra fire safety points. And that happens each time there's an iteration of design as well. It's really slow and kind of bloated process. As a result, we haven't seen open standard tools that can be built to connect the BIM workflow smoothly. There are some one-way transports. Some tools do take some IFCs, but it's really just for the geometry and that's it. Alluding to some of this lack of connection, the Hackett report in the wake of the Grenfell disaster called upon completing what they hoped was a golden thread of information. And I mean, it's a buzzword which has been used a lot, but it's really, really important. Really completing that data loop to try and ensure that key management items are covered through the life cycle of the process. And the International Fire Safety Standards Coalition recently came out with a call for a decade of action, primarily to address this lack of data standardization and also other lack of standardization in the fire safety engineering workflow in general and amongst the professional community, particularly looking at supporting audits, going towards automating compliance checks, and with a nod towards supporting those frameworks in global standards. So the original project scope was to encapsulate all of those primary aspects of the fire safety engineering workflow. So looking at calculations for fire, smoke development in buildings, basic calculations, simulations, strategies, evacuation, egress, the overall movement of people, circulation aspects, and some of the parameters where you might get counterflow, those kinds of things. And then within those hardcore analytical areas, you're looking at regulatory compliance requirements and how we look at the compliance of buildings to make sure that in the fire safety engineering world, that scope is covered. And over time, that was a few years ago, we started at the very start of the project. Since chatting to Nick, Richard and others, we've subdivided our work to get more focus. So now we have the fire safety engineering project, including the IDS work for fire safety engineering, which is now more focused on fire, smoke, and sort of communication of fire strategies and control strategies, and how metrics can be implemented to support the basic calculations and simulations. Overlapping with the fire safety world are things like evacuation, pedestrian movement in times of emergency, which overlaps with the general analysis of occupant movements within buildings, circulation, simulations, ingress, egress, counterflow, and regular usage of buildings. And obviously there's a lot of shared parameters as well. So there's two overlapping areas there, the fire safety engineering specifics in terms of analytical data and the occupant movement side, both within and without the fire safety engineering. And from the outset, there was an overlap with requirements on the regulatory information requirements project, how that is treated within compliance, but obviously compliance as a whole crosses multiple professional workflows as well. So because we sit within different rooms, we're slightly separated, but we're very conscious of the fact that these three all potentially overlap for the fire safety engineering workflow. So now we have this kind of split but interconnected split of the very specific fire safety engineering data. We had a call for sponsorship early this year, which was we did have some interest from and some degree of success as well. So looking for additional partners on that fire safety engineering project. And the occupant movement analysis side, which is already more mature, has undergone phase 1 development led by Jimmy Abdelain at the Technical University Munich, and is now looked after by Asim in phase 2 at the Greenwich University as well. Fundamentally, now within the sort of more narrow scope, the fire safety engineering workflow covers looking at aspects of providing data to ensure that with from the IFC model, from the BIM package, we can start to look at fire growth, how the material and the fabric of the building degrades within the context of the fire growing, how smoke and heat will propagate through the spaces within the building, how the fire protection systems are going to respond, suppression systems come into place, how that is then looked at in terms of risk assessment and also overall fire safety strategies. There's a wealth of things which will spur off those additional data streams. And one of the key aspects here is available safe egress time, essentially calculating when the building becomes unsafe to be in any particular place. And the occupant movement side supplies ingress and egress, circulation strategies. So that really covers normal movement, but crossing over with the fire safety side, we need to consider signage, exit routes, and the evacuation time. Basically, time to get through the nearest exit is the required safe egress time. And these two combinations, the available safe egress time and the required safe egress time, are one of the key steps towards compliance using what we call the performance analysis side of fire safety. And the performance analysis is important because when you look at the compliance of a building using performance methods, you tend to use medium to high scale simulations for these two aspects. On the other side of fire safety engineering, you have the more traditional prescriptive compliance route, which is pretty much everything done by essentially lots and lots of straightforward rules, but quite a complex set. So within fire safety engineering, we have the performance side, which is these more advanced simulations, and the prescriptive side. But many of these data points will be used to feed into both of those routes. And at that point, I'm going to hand over to Asim to cover some of the specific details about both tracks. Asim?
Thanks, Pete. I'm going to start with an update regarding the FSC project, one of the two projects which Pete mentioned. So at the previous BSI summit in March, April, we gave a presentation about the call for sponsorship, and the web page about this call is on the BSI's website as well, and you can quickly access it by scanning the QR code showed on this slide. I'm going to mention the funding situation, including any in-kind contributions and also further funding we are seeking. So first of all, we have applied for the University of Greenwich Vice Chancellor PhD student scholarship, and we are waiting for the outcome. Hopefully we'll hear from them in the next few weeks. And our industry partner OFR consultants have agreed to provide half the funds for that. And that's around 12.5K per year for 3 years. And the remaining half will be provided by the University of Greenwich. Of course, it depends on whether our application is successful or not. In addition to this, BSI will provide us with 10.3K euros for this project. And we have also received several commitments for the in-kind contribution, which I'm going to cover on another slide. However, we are still seeking more funds to support this project. So that's around 25K. So those who are interested in supporting this project can contribute smaller amounts, so let's say 2 to 5K. Next slide, please. So this is our current advisory group for this project. As you can see in this group, we have experts from various organizations and countries, both academic and from industry. When we get close to the start of the project, we will have clarity in terms of who will be part of the active project team and who will prefer to stay in the advisory group. But this is the group we have at the moment. Next slide. So as far as the next steps are concerned, as I said, we will wait for the next few weeks regarding the outcome of our VC PhD scholarship application. Our application is quite strong, so we are hopeful we'll get it will be approved. And then we'll start the process of recruiting a PhD student. So there is a possibility that the student will start work around spring next year. So the key part of this 3-year PhD work will be the IDS development. And in the first phase, we're going to work on the process maps and initial exchange requirements, while in the second phase, we'll move to full exchange requirement, IDS development, documentation, and obviously publishing research and so on. And as I said before, we have applied for scholarship, so hopefully this whole thing will be funded. And to support this work, we're also working on a prototype add-in. So the people who are working on this, they will be building on the work which has already been done at the University of Lund by Nazim as part of his MSc. So idea is to provide tools, or this tool that can work for FSC and OMA and help in the workflow. Okay. Now the second project, which is occupant movement analysis, MVD project. So in this project, we are covering, Pete has already covered this part. So we're just covering evacuation and circulation as well, both emergency, non-emergency movement, as you can see on this slide. Next slide. So this is our project team, and again we have people from various organizations and countries, and we have regular team meetings to discuss work related to this project. And so far we have made very good progress. Next slide. Right. So the progress so far, it is first of all, it's a 2-year project. We have completed phase 1. This project started in July 2021 and is expected to finish next year, June. So in the first phase, we produced initial exchange requirements, and we also created 3 process maps. We looked at the UK RIBA evacuation using UK RIBA stages, also a generic evacuation use case and a circulation generic use case. And these use cases have been approved by the BSI steering committee. In second phase, we are working on producing more detailed initial exchange requirements, and we're going to produce essential list of data points. So far, we have looked at various pedestrian modeling tools, and we have produced list of data properties supported by them. And based on that, we're going to produce one list that's going to cover all the essential data exchange points. Obviously, we're going to review the IFC model based on that list. And then the idea is to come up with an MVD based on that information. So as you can see, this is the sort of stuff we have covered so far. Just one example here. So the example here is about exit usage. So we looked at various tools. So the properties shown here are from what's supported by some of those tools. We not listed everything. In some tools, the more properties are supported as compared to others. So the idea is we identify the common properties which are different, and properties which we think are quite useful, and also properties which are optional. And based on that, we're going to produce one final list. Next slide. So I think I'll hand over to Pete. Pete is going to talk about the implementation side, which is related to this project. Thanks, Pete.
Your microphone is muted.
Thanks for the reminder. Yeah. So our presentation today is relatively short. I've got a few more slides here, and there's plenty of time for discussion afterwards. So essentially, as a complement to the work that Jimmy and Asim and the working groups have been working on in terms of starting to draft the enhanced standards for the MVD work, I supervised a student, Nazim, at Lund University, who's now since graduated and recently joined Jensen Hughes. And he was working on a prototype to implement the draft of these standards to take the data points within Revit, create an add-in, and export those data points into an enhanced IFC file and pass it into an external package. We chose Revit really as a point of demonstration. I was working at Autodesk at the time, which helped, but the approach that we adopted is specifically and really particularly not tied to any specific BIM tool. It's really meant there to create a tool. It is open source, everybody can look at it, and it's hopefully a good demonstration of the technology. So we got a few little clips of functionality here. Nazim's thesis was integrating fire evacuation into the building information modeling workflow, and essentially looked at adding different parameters to a custom interface. You can specify those parameters, calculate travel distances, look at the usages of space, There was also some prototype regulatory checks in there as well, just things like travel distance, just to show a full round trip proof of concept. But it is a working prototype, and is available. So looking at some of the basic functionalities, within that add-in, you can set the flow rates, occupancies of different rooms, basic regulatory requirements. It does enhance these kind of draft IFC files with these additional parameters. It prototypes the full data round trip. So we worked with Pathfinder, which is one of the more popular commercial tools for looking at pedestrian movement and evacuation. And they enhanced their release to bring in these extra parameters, just to show industry, if you like, that it was all possible. And that's now in the current release of Pathfinder. So it's pretty solid. We tested it in a different couple of scenarios, hotels and office buildings as a first starting point. And this add-in really creates the basis for this complementary functional work, because we found it helped engaging with industry to really show the benefit of these enhanced data standards behind the scenes, really the kind of functionality they can support. So looking forward, and in terms of the development of these projects, Asim's been guiding the work for process mapping, both in occupant movement analysis, and process mapping will be happening for the fire safety engineering side, but also we'll be considering the fire safety engineering workflow to make sure that both these two complementary MVDs and ISDs work together to ensure that all the data points are there. One of the points which we are trying to consider at the moment are how we consider, not just design scenarios, but let's call them life safety scenarios as well. So, for example, you might really, in a regular fire safety engineering workflow, you want to consider when one set of stairs is out of action, or one exit pathway is out of action. You want to make sure that the building is still capable of supporting safe evacuation during those times. Or you might want to specifically consider looking at fires in different locations around the building. All of those scenarios are really looking from a design perspective at the way in which the building is used or going to perform in those cases. There's no geometry changes. So we're considering if we can cope with those scenarios within one IFC file with just some additional parameters which state, the fires in this zone or in that zone or the other zone, or these exits are available. But we're expecting that if there's any significant geometry changes, we would probably need another IFC file. That's one of the things we probably need to tackle, I would say. But there's, I'm assuming, some knock-on for other MVDs and ISD works as well. We also are aware of the fact that BIM models have an awful lot of data in there, and a degree of that isn't required for our analytical purposes. So we're going to be looking, certainly from the add-in perspective, at ways of taking out the unnecessary information so we can streamline the workflow for these purposes, at least from a functional perspective in the add-in. Things like, the ironmongery on the doors, which wouldn't be analysed, very specific details on the door frames, window frames, etc., where the analytical packages don't take those things into account, and it just slows down the process. We mentioned that the complementary add-in is on an open source Git repo. So the link's there. We can share the slides anytime. And also, we've already just recently started to make sure that we've got branching and code collaboration going on. And we've just started, Accurate just submitted a quick test comment. So that's going to be developed over the coming months, in step with the development of the standards as well. And we'll be engaging with industry to make sure that those, the two stay in step as well. And that's it for the presentation side of of what we're doing. And as Nick said earlier, then there'll be hopefully be some discussion. I think Nick's going to cover how this sits within the regulatory room, and then we can have a chat about implications, possible engagements, etc., etc. So yeah, thank you.
And will you advance the slides for me? Okay, I've got a slide stack from the regulatory room. I won't make you sit through all the sessions we've had so far this week, but we have got some material which I think is very relevant to the collaboration that we need to put in place. So if we just click through a few slides, keep going. We don't need to talk about the role of rooms. Keep going. You don't need to know that we have a regulatory committee. Keep going. Keep going. Okay, we have a room charter about our scope, and we really want to complement the interoperability of built assets. Built assets are solutions, and we really want to make sure that we include in the buildingSMART universe requirements. There may be regulations, there may be requirements, there may even be recommendations. And our ultimate aim has always, well, is to move the industry closer to automated code compliance, using open BIM wherever possible. We argue a lot about what's possible. And to bring in the regulatory community into the buildingSMART orbit. So we'll just keep going. One more, please. That's like, is there a clicker I could use? We needn't talk about that. Some of you will have seen Canadian cities talking about their plans for compliance checking. Keep going. Keep going. We've got a roadmap, which we've just finished revising today. The old roadmap that was 4 or 5 years old had a lot of detail on it, but no dates. In recent years, we've got a lot more involvement. We've got a larger steering committee. We've got a larger support community. And so our new roadmap is going to put dates on our ambitions. We're hoping to be able to set some timetables. And the most important aspect of our current plans are 2 projects we've got underway. The first one is that we want to prepare guidance for regulators about the importance of open BIM. In general, and I've been caught out with this statement this week, so in general, regulators don't come to buildingSMART meetings. They don't come to meetings, let's be honest. They're part of government and they don't necessarily engage. And so we want to produce a document that we can put under their noses so that they can't ignore, saying that open BIM can be part of an improved process. It doesn't have to be costly. It doesn't have to be proprietary. It doesn't have to be a big bang of moving to automatic code compliance in one step. We can do it and so on. So we're gathering case studies, and I have a feeling that the work of this project will be one of those case studies. But we're also laying out an agenda for people to follow and hopefully to understand what the role of buildingSMART is in the industry. The second project we've got underway is the Regulatory Information Requirements Project. And this is really inspired by the fact that there's a lot of local projects looking to start to implement automated code compliance checking. 20 years ago, I worked on the Singapore E-Plan check project, which was very successful in all sorts of dimensions, but it wasn't maintained, it didn't persist, it wasn't sustainable. And so we've been looking at the reasons, and we're trying to get back to the point where if the building models have enough information, and particularly the things that are universal, then there's more chance that code compliance will become a more common feature. So every country has different regulations, but they all regulate the same things. It's always fire, it's always structural safety, it's always aspects of environment and waste, it's always, nearly always, accessibility, and so on. So there are some commonalities that, although the regulations differ, the data they're based on, we think we can find commonality. So if we just click on a few more steps, that's today, so let's move on to one more. And so we had an early discussion about the liaison challenge with this project, looking at fire simulation, and I appreciate it's been split into two, and the role of regulatory information. And simulation is not the same as regulation, or doesn't have to be the same. Just as an aside, in the UK, we've just completed a project called DCOM, Digital Compliance. 4 years ago, we did a pilot to show that automated regulatory compliance could be done. And this DCOM project was to show that it was scalable. And we took the three main parts of the UK building approved documents, fire, energy conservation, and accessibility. And in a few months, we had them all automated. And one of the ways we did that was that we separated the problem into making machine-readable regulations, and we found an efficient way of doing that. And then we had a rule engine, which was universal, which in fact, it was an off-the-shelf rules engine. And then we had separate servers holding the building model. And we also had a server that was doing energy analysis. And that's, in the UK, it's called SBEM. And it's a simplified building energy model. And it all comes down to, is the building's emission rate more or less than the target emission rate? And so we're able to say to that service, that information isn't in the building model. Can you as a service run an analysis and answer the question instead, and then feed it back into the process? And that struck me as being very similar to the equation or the comparison that we saw on the screen. Is the achievable evacuation time more or less than the target evacuation time? And so I can see a future where simulation is more accessible. And so if you can't or don't want to meet the prescriptive regulation, you could automatically switch over and say, please do a simulation to see if we meet the regulation, or the other way around, and so on. So that's quite exciting. Let's go to the next slide. And we started to, yes, the regulatory room information requirements. Our three main targets are fire and structure, energy and environment, waste, in other words, and accessibility. And in the building room project, again, the three quadrants, and we can see that between fire structure regulation and the regulation aspect of the project, we needed to work together. We drew a diagram to see if this idea could work. So next slide. And this was purely hypothetical, and there are experts watching this who may spot a few mistakes in what we said in the initial draft. But both whether you're doing simulation and performance or whether you're doing prescription, there's a common context: building type, zoning, occupancy, and activities, identification of the different systems in the building. Whereas performance may be looking at typical occupancy, material properties, surface properties, space contents. In the prescriptive world, we look at assumed occupancy. We look at specific system characteristics, material ratings, surface ratings, and it may all be affected by the jurisdiction. So we drew a map of how we thought things might divide up, and we need to follow through on that now that both projects, the Regulatory Information Requirements Project and the fire engineering projects, are starting to produce results. And I'd really like to look at the models you've been producing, because we've already got the requirements, the regulatory information requirements from Finland, Estonia, UK, sorry, I should say England and Wales, from the DECOM project. And we've got sponsorship from Scotland to look at their regulations. And this morning we started to have conversations with the Netherlands, with Germany, with Czechoslovakia, and I think I'm tempting a Canadian organization to get involved. And so we're starting to find the commonalities for the regulatory information. What we need to do is to find out how much of that is of interest, how much that can be shared with the fire engineering. A couple of, I think, next slide, please. Okay, so this is a quick summary of where we are with our regulatory information requirements. We had a big discussion this morning about the project and how the IFC schema does give us the platform we need. It represents the spaces. It represents the physical stuff. And if necessary, it can represent the process side, which isn't always, well, it's more relevant to the construction and maintenance cycles. But so we're confident in the basic idea that the IFC can represent the problem for regulatory compliance. I hope that the project is finding the same thing about the IFC for simulation. But I think the exciting thing is that prospect of either that projects will be able to choose whether they go down the prescriptive compliance route or the simulation compliance route with hopefully 75, 85% the same model. And I think that's really exciting because it means that the advances that are being made in simulation can complement the sort of fairly static approaches that are in the regulations and so on. So that's a bit of a vision. Yeah, I'll stop there, I think, and say, let's have a bit of a discussion.
No, I received a proposal out of the University of Eindhoven, the ETA for FICON. It was prepared for the European Committee, and it was declined last year, but they want to renew it and update it. And they asked me if we, one of the BuildingSMART Benelux, wanted to participate. And then, of course, I saw this proposal by, so why not do it from international perspective together with BuildingSMART international community?
Yeah, well, we have two ways of engaging with our project, which you can either be a financial partner, whereupon you can help to steer the project, but we will take any well-structured suggestions anyway. And I think it looks like from Germany and from the Czech Republic, they don't have a means of funding support, but we can give you guidance on how we would like to have that conversation.
Yeah, I think that would be easier because there are also Denmark is participating, Norwegian is participating in the same product proposal university. So it's a broader group than just Eindhoven. So
I mean, that's exciting. And I know that when we get into discussing European projects, there are two considerations in my mind, having accidentally left Europe. One is that the European case is special, and as BuildingSMART International, we have to look at it as being an example. But we can also look at the European case as being on the leading edge.
Yeah.
That actually most of the things about the advancement of BIM have happened in Europe or the UK over the last 30 years. And so we should always pay particular attention to the European angle, because for all sorts of exciting reasons, Europe is usually on the forefront of these questions.
Yeah, but maybe we should discuss the proposal in the project working group meeting. I can share the proposal that I received and discuss it with.
I think that would be really exciting to get that going. So, you know my email, you know where I live. Okay, good. And there's a mention of a research paper, which there's one other thing I'd like to mention, and you may be cross with me, but the last 2 years I've been working on the Ports and Harbours infrastructure project. And as part of that, we looked at capacity planning for ports and harbours. In other words, how big a ship can you get in? How many containers can you offload it? How big is the storage area? How frequently can lorries come in and out carrying containers? How frequently can trains come in and out? How many containers get delayed in customs? And so on. And we added to the IFC schema at 4.3 2 property sets, one for spaces and one for equipment. And with that, we are able to predict the annual throughput of a port in terms of 20-foot container units per year. Now, I know people moving around a building wouldn't want to be thought as being small containers, but it sounds like there's an overlap between those kinds of analysis, which for ports is really important because they wanted to maintain the capacity. What they were talking about was that during detailed design, extra buildings are added, like a customs house or a bonded warehouse or something or other. And no one rethought the impact on the throughput of the port until it was too late, and then the throughput was disappointing. So I think we could, when we look at the work that's coming out of the fire simulation thing, we should look also about whether it's applicable or whether it overlaps with the capacity planning from other kinds of facility. That may be a very naive analogy, but I think one of the things that we can do in buildingSMART is find those similarities, find those opportunities to say, flow analysis is a key part of any facility performance, and we shouldn't necessarily look for 2, 3, 4, 5 solutions when there might be one unified one. Just a thought. Any other comments? Asim and Peter, do you want to follow up with any more remarks?
I saw Christian's paper he put in the comment window. That was helpful. I think we've looked at that before. We'll be sure to include some of the things in that paper. It was from a few years ago, so we'll be sure to include it. Also, there's a question from Alexander about ITEA4, fire code unification for building information models in the Benelux chapter. I've not seen that in any detail. Asim, have you seen that?
No.
Alex has presented, I don't know if you could hear, but he made some remarks about that proposal and how it might feed into the regulatory room.
Ah, okay, we couldn't hear that point. Yeah. Okay. Yeah. Could somebody send us that information then?
Alexander Warp. I was approached by the University of Eindhoven. If you
sorry.
paid
my-
the ETR4 project.
Yeah.
And
Yeah.
I thought it would be good to do it internationally with the buildingSMART international project that's ongoing. So maybe the next, I propose, maybe the next working group, I can present the proposal they're writing on. It's a really broad proposal with a lot of universities in Europe, from Spain, Denmark, Norway. So that's, maybe I think it's good to try to catch up and be a participant in that proposal.
Yeah, understood. Sorry, I did hear what you said. I just didn't realize it was the IETEA4. Absolutely, yes, yeah.
I will send the proposal, the one I will share it with this group.
Okay, perfect. Yeah, thanks. And if you want to be on our next fire safety engineering group meeting, happy to add you. Yeah, for sure. Any other questions?
Any more questions? So, maybe So if there's no any more question, we could just end up the presentation. Thank you so much. There's, I think, 30 minutes left. I appreciate your presence here. I think I'm looking forward to see you for the next session and at the end of the meeting at 6 o'clock. Yeah, thank you. Thank you. Collaboration. Thank you so much. Merci.